have to start with my disclaimer that says I'm here today as an independent consultant. The views I give you will be my own and not those of the National Wound Care Strategy or of NHS England. So, as the title infers, we want to talk about why we're measuring interface pressure. And I think it's really important that we think about what this means to us, because it's something you'll hear talked about when you're in clinical practice. Lots of companies who come to us to talk about mattresses and cushions will use interface pressure as a way of demonstrating the efficacy of their product, of comparing it to other products, or saying why it might work for a specific group of patients. And what interface pressure does is tell us about the effect of an external load and the impact that has on the circulation. And we believe that you have to exert a certain pressure to cause that damage. So it has to be enough to occlude the capillaries. So putting that simply, what we are thinking about is we're applying that external load to the skin. And this always seems a bit counterintuitive. I've got it going downwards, but actually if you think about it, the load's going upwards. It's coming from the surface through the skin. And it applies itself through the tissues onto your circulatory system. Now remember, it's the arteries and the veins and the lymphatic system. It's not just arteries that we're thinking about. And it compromises those. What it starts to do is it causes a degree of hypoxia. Now, in normal healthy individuals, when you get that degree of hypoxia, you start to fidget. You get like a pain pressure response and you relieve the pressure. But if you're unable to do that for any reason, the circulation is finally compromised enough to cause ischemia. The localized tissues die. So the basic assumption is if sufficient pressure is applied, there'll be occlusion of that vasculature and you will get localized tissue death and necrosis. And that's what we're all aiming to avoid. In pressure ulcer prevention, we don't want to get to that stage. But there are some basic flaws in that assumption. And the flaws are multiple. We assume that if you put a pressure on the surface, it's applied directly in a straight line through to the bone. But we know it doesn't happen that way. Different tissue types have different properties. The skin is really strong. It's very resistant actually to direct pressure. If you think about, any of you like reading detective stories, I love a detective story, all that CSI thing. When bodies decompose, I know it's not long after breakfast, all the internal constituents liquidize, but the skin remains, doesn't it? The skin's strong. But it's not strong in other directions. Direct pressure, it doesn't affect it as much as internal pressures. There's some push back on the external pressure. So think about the difference between your arteries and your veins. Your arteries have got a high internal pressure because your heart is pumping and they're elastic. So they're pushing outwards against that pressure, pushing inwards. And they mount a response to that pressure, the inflammatory response that we know about, and it causes increase of blood supply to the area. And disease processes affect all of these. So actually, if somebody is hypertensive, they've got high blood pressure, pushing more through the arteries, there's more push outward, there's more resistance to pressure. But if they're hypotensive, lower pressure in the arteries, easier to compress them and collapse them. So thinking about why interface pressure is relevant and why is it important? So I'm sure you've all seen some kind of diagram like this before that shows you the difference between the arteries and the veins, and you have the capillary bed in the middle, and that shows you where all the things happen. So in the capillary bed is where the fluid and the nutrients and the oxygen is passed out to the tissues. And we have the Landis study. The Landis study is our benchmark study. It comes from early in the 1960s, and that's where the 32 millimetres of mercury comes from. So if you read anything about interface pressure, they will tell you we're trying to get the pressure less than 32. It's always got to be less than 32, because that's what the Landis study said. 32 millimetres of mercury is capillary closing pressure. But that's not quite the case, because it's the mean capillary closing pressure. And if you look in the arteries, you'll see it's different to in the veins and different to in the capillaries. Does that matter? If you think about your vessels as a roadway system, any of you travel here via a motorway or drive on a motorway, if there's an accident on a slip road up to a roundabout, what happens to the rest of the motorway? That gets backed up, doesn't it? And it's exactly the same with the occlusion of your blood vessels. So you can see that in the venous limb, the capillary the closing pressure is only 6 millimetres of mercury. So if you put more than 6 on, you start backing up your venous system. And it depends on the size of the vein, doesn't it? Some big veins are better than some small veins. So what happens in the arteries is different what happens to the veins. So we really need to think clearly about how much we believe that 32, which we believe it, it's real, it was measured, but what relevance is it to our patients? So when we're thinking about this measurement, we need to think clearly about what we're doing with it. Why are we using it? Does it apply to our patients? And are we using it as a comparison between two different pieces of equipment? Are we doing it as a comparison of pressure across a whole surface? So are we balancing the patient's weight out? When we talk about reducing pressure, we talk about spreading the load, don't we? So the more points of pressure contact we've got, the less there is at each point. And thinking about identification of how to change or alleviate pressure. So do you all teach things like 30-degree tilt? And what you're aiming for there is to reduce the pressure, but do you know if you've done that? If I asked every one of you to put one person in 30-degree tilt, I bet you'd all do something slightly different. And if we measured the pressure underneath that patient, we'd get a different response. So we know we need to get the right amount. So this is slightly embarrassing. These were my first forays into interface pressure measurement. And when I worked originally in my first tissue viability post, that just say 1993 at the bottom, it's one of the things we did. It was all we had. So when I did my first mattress audit, I was pulling out horsehair mattresses and the old, crinkly staff check mattress covers and things, and we needed something better. And there was this growth of mattress companies saying, my foam's better than their foam. So we had to have an objective comparison. So what we did was interface pressure monitoring. And you can see I had a lovely engineer from the wheelchair services in Sheffield who helped me learn about interface pressure monitoring, and he brought his seating mats with him, and we very carefully placed them under the patient. Those are diagrams of where we place them, so I'm just going to show you how patients were semi-recumbent or side-lying. That's important because that's kind of how we put patients, isn't it? Not many patients lie flat on the back. But when we get presented this interface pressure now, this is the kind of thing we see, isn't it? This kind of heat map, this colour that tells us where the high spots of pressure are. And we know that red is the signal for danger. If you've got red spots, that's high spots. So you might be looking at the peak pressure. And if you look at the one on your left, you can see this patient doesn't sit equally. So this is probably a patient who's had something like a CVA. They tend to have a weakness on one side, so they lean on that side. You can see that in the buttock mapping. Whereas the one on the right has got a much more balanced pressure, and we might be there looking at an average pressure. Is that too high? Can we lower it by putting them into a surface with more immersion and envelopment? So there's got more contact surface, so less high points, and get them down to just yellows and oranges. But pressure's only a small part of the story, because you can all tolerate a very, very high pressure for a small amount of time. If I asked some of you to just perch on the edge on the window for a little while, you'd manage it for a couple of minutes, and then you'd say, I'm bored with this, I want to sit on there because it's hurting me. So pressure and time is important, effects of shear are important. There's a whole range of things. So we can't just say the interface pressure is different, therefore that's the better thing. So when we're interpreting these interface pressure measurements, we need to think a little bit about what else goes behind it. And I pointed out to you what I did with my patients. You can see these are very typical maps that you'll get on commercial mattress information. You have got a patient side lying, but what you have got is a patient lying flat on their back. So that gives you maximum weight distribution, doesn't it? You haven't got that. As soon as you start to sit the patient up, remember we want less than 30-degree head of bed elevation, you're putting far more pressure through the sacrum. You need to know who is this done by. So if it's done on volunteers, do you think your tissues are the same and their response is the same as those of a patient? Or those of a frail elderly patient who is very deconditioned, they've lost a lot of muscle mass. Their ability to distribute the pressure and to respond is completely different. And an indenter is something else altogether. See if the patient they're in, the position they're in is similar to the positions your patients will be using. And think about the type of monitor that's being used and the number of sensors, the type of sensors, and the minimum and maximum readings those sensors take. Because if you're looking at an average pressure, if the sensor only reads up to 150, it's going to cap the number, which will reduce your average. If it's done with a different type of pressure mark that reads up to 250, the mean can be much bigger, can't it? So if you're thinking about who or what the measurements were done on, you get this whole range. So you need to ask the questions. Were these people, volunteers? Were these patients? If they were patients, tell me a little bit about the demographics. If they were done on indenters, so sometimes you'll see these whole body indenters, these are really good because you can place them in a reproducible way. So one of the problems we had when we did our study was getting the body, which was me, in the same place each time. And what we did was we just drew randomly on the mattress because we checked it when it was new after a month, after 3 months and after 6 months, because you know the profile changes. So we just drew randomly and I had to lie in the same position next time. But with these, you can put them down easily because when you get on a mattress, you scrunch everything up. So if there's a pressure mat, the chance of screwing the cells up is quite high. So we've talked about the subject, and there are other factors that might affect what you can read and how you might read it. And the sensor themselves is really important. So when my very first ever one, which was before the one you saw that I never published, was, does anybody remember a Spenco mattress? Right, so we were looking at Spenco mattresses and they brought me this handheld monitor. The cells were this big. We were measuring pressure under heels and it was like a balloon. And basically it depended where you put the heel on the thing, whether the balloon blew up or not. So in retrospect, what we were doing was a bit on the dubious side, but it was a start. But there are many things about the artefact of the sensor, and the shape of the sensor and the size of the sensor really make a difference to the measurement and where you place it. So if you think about putting them under somebody's buttock area, if you miss the sacrum, or if the semi-recumbent, if you miss the ischial tuberosities, you're going to get a very different reading. So you need a mat that's big enough to pick those up, and sensors that are small enough to record individual points of pressure and not allow for ballooning around, depending on how the sensors work. So we tend not to have the air-filled ones now. They tend to be more strange gauge responsive. And whatever you put between the patient and the mattress, so if you're using an interface pressure mat, then that has surface properties, doesn't it? It's not as stretchy as the cover, and that will have some impact on the readings that you get. So when you're looking at them, ask questions about them. Were they done in lab conditions? Of course, that's going to be more repeatable. You can control all the things that affect the sensor, the time, the temperature, the humidity, and the reproducibility of the patient. The surface on which the measurements were made. So if you've got your sensors all in a big mat, so it's mattress size, if you put that on an alternating surface, what happens when that cell inflates? Think about the tension on that mat. That's going to pull on that sensor that's up, isn't it? It's probably going to pull on the sensor that's down as well. So you're not really getting a real reading. So all those things are important. And smaller sensors are much more accurate than big sensors because you don't get displacement. I briefly mentioned immersion and envelopment, and this is just an example about how you spread the load. So you all know the equation for pressure is weight divided by surface area, and that gives you your points of pressure. So if you put the patient on a hard surface, you only get a small number of contact areas. There's going to be a high interface pressure at each of those. If you have a surface that they can immerse into or that envelops them, you've got far more contact area. Still the patient's weight is the same, so less pressure at each area. The sensors themselves have a degree of error. Everything we do has a degree of error, doesn't it? And we need to think about the accuracy of the sensor. So any pressure monitoring system that is being used, the manufacturer's instructions will tell you the degree of error on this is 1%, 2%, 20%, whatever that might be. And they vary substantially between the systems. So that's a question you need to ask. Which system did you use? What's its degree of error? And you might say to me, oh, if it's 2%, Jacqui, does it matter? Does that matter? Well, you need to think about what's clinically significant. Is it a percentage? Is it a number? Is it 1 millimetre of mercury? Does 1 millimetre matter? I don't really think so. But where do you draw the line? 2, 3, 4, 5? And does it depend where you are? Is it at 5 millimetres of mercury? A difference of 5 is a really big difference, isn't it? But if you're at 242 millimetres of mercury, a difference of 5 is really neither here nor there. So you need to think about what they are, but also think about those in terms of percentages. That's a percentage reduction. So you know when we look at wound size, we don't go that's reduced by 1 centimetre, we go it's reduced by 10%. because it depends on the size of the wound to start off with. If your wound's this big, a centimetre is not very much. If your wound's that big, it's healed. So a typical monitoring system has a sense of error of accuracy of 5 millimetres of mercury at each point, okay? So let's think about that in terms of percentage. If you've got 30 millimetres of mercury, that's a 17% potential error. Sounds quite high, doesn't it? 17%. Think about that in terms of other clinical things. Would you accept a 17% degree of error if you took a temperature reading and it could be anywhere between 30.8 and 43.2? Would that be acceptable to you? No, not at all. Pulse, 63 to 88. It's not great, but I'm less bothered about it. Blood pressure, again, not as wild. ABPI, the difference between 0.75 and 1.05. And if you're 30 and somebody says you're 25, you're very pleased. And not really pleased if they say you're 35. So it does matter, doesn't it? We need to think about it. So think about also how they present it, because we tend to talk in absolute numbers. I said to you 32 at the beginning, and that's quite meaningless. So if we talk in absolute numbers, really, does that matter? Because you can't change the patient's weight. The patient's weight is the patient's weight. The only way you can change it is increase the contact area. So what you're looking at is distribution. You're looking at percentage change. You might also be looking at cyclical or cumulative pressures, because I also said you could all go and sit on there for a couple of minutes. So what you want to know is how long that really high pressure is maintained for, and how long a change is there for, and how much you've got in lower pressures. And you want to think about statistical significance. Do you all love stats and you see that nice p-value and then you look at that, that's 2 millimetres of mercury. Does it make any difference? What's the clinical significance? So statistical significance is important, but actually clinical significance is more important. So let's think a bit about what you've seen with interface pressure. So this is no reflection on this study. This is a more recent study. It's from this year, and you can find it online in Journal of Wound Care, and it's by a very well-respected author. So if we look at what it says, so hopefully this was done with the patients lying supine. Do you lie your patients supine, flat on the back much? So is it relevant to your patients? These are healthy people. Are they like your patients? Is their ability to move, fidget, the same as your patients? Pressures were calculated. That's an interesting word, isn't it? I'm going to calculate that. Is that done on the back of an envelope with a pencil? Is it done with a calculator? Is it using a statistical monitoring system? We looked at contact surface area. So how big was that? How much of the patient was it? And peak and mean pressures, two different things. Understand the difference. This patient sat on one IT. This is the average across the whole of them. Peak pressure index. Does anybody know what the peak pressure index is? It's some calculation of we take that peak pressure and we multiply it by all the peak pressures and we do it over time and we come out with a number. And we did it for 21 minutes. 21 minutes. Why? I mean, I don't know. I genuinely don't know, and to be honest, I didn't read the rest of the paper. I just thought there was a good abstract to choose. My supposition on this is, when we, a long time ago, when I was doing that work we were doing, we were relying on some very old sleep studies. Some of you remember a really old yellow mattress that had a 7.5 minute cycle, not the 10 minutes we have today. That cycle time came from sleep studies about how often average people move in sleep. So my only supposition is that's 3 sevens. So, but I don't know. That's just me guessing. So if you're thinking about using IP to choose equipment for your organisation, you really need to think about what do you need to know, what are you using that information for, and what else do you need that goes alongside that information. And there are some really good examples of how you can use interface pressure and how you can use it really well. Can I just ask anybody in the room, because I can't see those of you online, has anybody used interface pressure monitoring actually themselves, not read it? Nobody's used a pressure map. So 3 people in the room. I'm hoping some people online. So you have a feel for how this works and how complicated it might be. And I want to give you some examples of where actually it might be quite useful for you, and you might see examples of this published and think, that's interesting, that's something I could use, and it has a practical application. So beyond saying, I need to tender for new equipment for my organisation, and got these 7 companies, I'm going to look at all the interface pressure profiles and make my decision on that. Not a wise decision, shall I say. That is not a good way to choose a mattress. These are things you might want to think about it. So some of you may know Nikki Elwood-Wotton, who is a doctoral student from Southampton, working with Pete Worsley and his team down there. And as a community TVN, she had lots of community nurses saying to her, we've got this patient and they're non-compliant with their mattress. And I use compliant, they're non-compliant with their mattress. And Nikki would go and see the patients, and as a TVN you have a bit more time than a community nurse. Community nurses' caseloads are horrendous, we know that. They are struggling to get through their day. So as a TVN you go in, you have a bit more time to talk to the patient about what it is that's wrong. Why are they non-compliant, non-concordant, non-adherent, whichever word you choose to put in there. And lots of them said, it's just uncomfortable. And lots of them said, well, when I get in it, I can't get out of it. And lots of them said, doesn't fit with my lifestyle. So does this sound like your patients? I don't like it, I don't like the noise, I don't like the colour, it has a funny smell, it moves. Once I'm in, you know, my mobility is not good and the edge is not firm, so I'm scared of getting out in case I fall. Lots of reasons why the patients were not using the mattresses. And lots of them said, I don't understand why I have to use it. What's the point? What difference does it make to me? So Nikki started to look at how she could work with patients to find the best solution for them. And isn't that what person-centred care is about? I only learnt recently when I went to EPWAP, the Pressure Ulcer Panel meeting in Leeds, the difference between patient-centred care and person-centred care, and I'm a bit embarrassed to admit that. Some of you are looking at me going, go on, explain that then. So my understanding of it, of patient-centred care, is we have a clinical objective that we need to achieve, but we ask the patient about it. But it's about achieving our clinical plan. Person-centred care is asking the patient what they need and thinking about how we achieve that. And it's very different, isn't it? Very different, doing those two things. And that's what Nikki was doing. So she worked with them with pressure mapping to show them what the equipment was doing for them, to work out if they tried a different mattress, whether actually that gave them a different profile. She didn't put it under them for 21 minutes, she put it under them for 48 hours. Think about when you go to bed. When you get into bed, are you in your comfy position? Or does it take you a good 10 minutes to settle into the mattress, get your best comfort? She left it for 48 hours and she showed them, if you cross your legs, this is what happens. If you move your arm, this is what happens. If you sit up and read, this is what happens. And do you know what? Every single patient accepted their mattress because they worked to find the right one for that person, and it made a huge difference. They've also been used a lot in education and feedback. So again, if you go to the literature, you'll find several studies, most of them done in Scandinavia, looking at use in education and feedback for staff and for patients. And you can see this particular study from Gunnenberg and Carley showed that when they used them in their training sessions, they got reduced pressure for pressure ulcers, and they got benefits in terms of when they mapped them, they'd got reduced peak pressures, they'd got number of preventative interventions were being increased. So staff were seeing the reading on the monitor, they were seeing the amount of red and thinking, oh, I need to turn this patient, or I need to reposition this patient, I need to move a leg, I need to put a device in situ. And that real-time visual feedback for staff meant something to them. It wasn't this abstract, here's a tick chart that says turn every 2 hours, tick it, right back left. It was, look at this patient's skin on a monitor and see where the high points are, do something about it. And then a further study by the same team, slightly extended team, looked at the impact of using it in training on staff, and they changed their pressure ulcer knowledge and theory skills scores because it meant something to them, it was real. And again, they had changes in the pressure sensors, and they felt that this really made a difference for their staff. So used in education, rather than used to compare mattresses, you saw a change in behaviours. And for most of us, isn't that the problem? You can put the best equipment in the world in, but if they just go in mute, 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 or not even putting the patient on it, or doing all the kind of random things that some clinicians do, it's not going to work. So hopefully I've made you think a little bit about the clinical relevance of interface pressure. It is a form of measurement, but it is one form of measurement. And to use it, you need to understand it, and you need to understand what can go wrong with it. So hopefully it's made you think, and there's some recommended reading.